guys with us. I hope you guys are ready and amped. What we are going to be doing right now, if you haven't been to school yet, or you have and you guys just haven't quite started yet, this is exactly what you're going to be doing in class right now. It might be a little bit jumbled, but this is what your teachers are going to be going through. And we're going to be talking about the real number system. Now, you guys can put this in the chat for me if you'd like, or you can raise your hand and let me know. Does anybody know what this funky looking N over here and this NO stand for? Anybody know? Apiwe knows. Excellent. Apiwe, what does the N and the N with the O stand for? You can unmute and let us know, my sweetie. Don't forget to unmute.
I think it is a real number, if I'm not mistaken.
Oh, no, but it is, you're on the right track. You're using the right type of terminology. It's just not a real number. Okay. I think you may have missed it a little bit. Anam says the number for the N. No. For N, okay, it has something to do with counting numbers. Do you remember what we call counting numbers in maths up here?
Yes.
What do we call them? This one also starts with an N. Tiana's got this one right. This is a whole number. These are whole numbers. What does the other N stand for? What does this one stand for?
Natural numbers.
That's it. Exactly. 100%. And for natural numbers. That's it. Well done, up here. That's exactly what I was looking for. That's it. It stands for natural numbers. Okay. And natural numbers are your counting numbers, like 1, 2, 3, 4, blah, 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 blah. And we keep going. Now, the difference between natural numbers and whole numbers is that whole numbers just include 0. So we start at 0. 1, 2, 3, 4, da, 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 and off we go. Okay, so natural numbers and whole numbers are counting numbers. Like if I have 16 sweets, I can count 16 sweets. Okay, this next one, does anybody know what the Z stands for? And this one is a quite important one. We're going to be coming back to this one again in a bit.
Ma'am, is it integer?
It is an integer. Excellent. These are integers. Good. What is an integer exactly? Who can explain to me what integers are? Hatu, if you're still there, you can tell us. Okay, let's see if Angel can tell us. Angel, what do you think? How do we describe integers? How would we describe them? You can unmute, look for the speak button. If you're on a phone, look for the speak button and then you can speak.
Okay. I can't say anything, understand.
Oh, okay. All right. I'm going to need you to do me a favor. I need you to leave the chat and then come straight back in. Okay. Okay. I need you to leave, come right back in. Okay. Excellent. All right, Lusanda, can you tell me what is an integer? How do we describe integers? Give me an example.
Miss, an integer is a positive and negative whole number, including the number 0.
That's it, 100%. I love how you said a positive and negative whole number, including, I couldn't have put it better myself. Well done. That's exactly, I think you're taking my job. You need to slow down. Slow down. Okay, excellent. What we're looking for is positive and negative whole numbers. And that's the one thing I was going to emphasize the most. Okay, there's 0, there's positive 1, positive 2. Then we've got negative 1 and negative 2 going in that direction. Now, exactly like Lusanda just said, they are positive whole numbers. So we cannot, under any circumstance, include negative 1, 5. Negative 1, 5 is not an integer. It is not included. Okay, we cannot include it in here. We're looking at whole numbers. So we can only include numbers like negative 14 or positive 7. 7, 9, no, that doesn't count. We are only looking at positive or negative whole numbers. Okay, that's how we look at integers. Hi, Tiana. You can unmute and ask your question if you do have one, my sweetie.
My question is, but like, what about like when you work with the Cartesian plane? Like, isn't there like a negative comma 5, 1, 5?
There is, but that's because the Cartesian plane exists within a real number space. Okay, not integer numbers, real numbers, and we're going to get there. Okay. Because yeah, the number line on a Cartesian plane is actually in real numbers and not in integer numbers. We just express it with integer numbers, but everything in between still counts. Okay, and we're going to get there. All right, who can tell me what does the Q stand for? What is Q? Q and Q apostrophe. I don't know if your name is Roma or Roma. You need to tell me how to pronounce that. Can you unmute for me?
It's Roma, ma'am.
Excellent. How are you, Roma?
I'm fine, thanks. And how are you?
I'm excellent, thank you. Can you tell me what does the Q and the Q apostrophe stand for?
The Q stands for rational numbers, and then the Q apostrophe stands for irrational numbers.
Excellent. That's it. That's exactly what I wanted to hear. Rational and irrational numbers. Now, the way we're going to be able to tell the difference, a rational number is any number that I can write as a fraction. So if I can write something over something, it's a rational number. So a rational number is going to include everything like natural numbers and whole numbers and integers. Because if I have the number 2, I can rewrite 2 as 2 over 1. I've written it as a fraction. Okay. Then if I look at a number like 2 over 5, that's a rational number. Okay. And this is where I think Tiana was getting at. Rational numbers and real numbers, they exist on this plane because I can take 2,5 and I can write it as a decimal, whereas integers, I can't write them as decimal. Well, I can write 2,0, but that completely defeats the purpose. This 2,5, I can write as 0,4. Okay, so I can write rational numbers as decimals, and I can also write them as fractions. And then we need to look at irrational numbers. Now, if we think about irrational numbers are going to be numbers that pose quite a big problem. Now, if I had to ask you guys, fastest fingers first, I need you guys to be on your chat function. If I ask you guys, what is the square root of 25? What is the answer? What is the square root of 25? Pop it in the chat for me. That's it, part 2. Well done, Apiwe and Dokozo. I see you guys. That's it, Simpiwe. It's 5. That's an easy enough number. And then I say to you, what's the square root of 16? Pop the answer in the chat. That's it. Well done, Misanda. There we go. Good. These are not irrational numbers, by the way, Liku. I hope I'm saying that correctly. Liku. Okay. These are all rational numbers. They are whole numbers. They're natural numbers. Okay. Until I ask you guys, what is the square root of 5? Now I've got an irrational number. What's the square root of 5? It's not a perfect square. That means you're going to have to go into your calculator and you're going to have to find me an answer. What is the square root of 5? Anam says 2,24. That's it. Good. 2,24. But I know that you're all rounding off. Okay. Don't round off. Give me all the numbers. It's not just 2,24. Lay it on me. What is the square root of 5? Something, that's it. That's what I'm looking for, Simpiu in part 2. That's it. It's 2,236. No, I'm thinking I'm writing and I'm not. 6067977. Exactly. Yo, Liku, I honestly feel like you guys are gonna ace this. Okay, good. It is non-terminating and it's non-recurring. What that means is there is no pattern after this 2 comma. It's just random numbers put together. I cannot put this as a fraction. No, Anam says, so ma'am, will we have to write it out fully in a test? No. And by the time you get to matric, they won't even ask you for a decimal unless you're calculating for a distance. They're going to ask you to keep it like this. Leave it as square root of 5. They're not even going to ask you to go put it in a calculator. Okay. But for the purposes of this, we're looking at the decimals that go there. They're not recurring. And what does Liko mean when he says non-recurring? He's talking about numbers like 1/3, because 1/3 can also be written as 0,33333, and it keeps going. But there's a way that I can actually take 0,33333 and write it as 1/3. Or I can even take 0,66666. That's the same as 2/3. I can actually write it out like this. I can write it out as a fraction. This is going to give me a problem if I have to write it out as a fraction, because even your calculator didn't give you all the numbers that go that way. Okay, there are more numbers, your calculator just didn't give them to you. Okay, so irrational numbers are numbers that don't have a pattern. This section over here doesn't have a distinct pattern, and I can't take that pattern and write it as a fraction. And that's the difference between natural numbers and rational numbers and irrational numbers. Okay, these are the things that we need to remember. Can I just get a thumbs up from you guys? Do we understand the difference between natural, whole, integers, rational, and irrational? You can use your reactions, or you can drop it in the chat while I take Apiwe's question. Do you want to unmute for me, Apiwe?
So the square root of 25 is not an irrational number.
No, it's not, because I can write the square root of 25 as 5, and that's the same as 5/1. Okay.
Okay,
So
thank
exactly
you.
Excellent. Part 2, what's your question, Maswidi?
Ma'am, I wanted to ask, so under irrational numbers, sorry, under irrational numbers, we have surds, non-recurring, and non-terminating.
That's it, yes. Non-recurring. So there's no pattern like 0,33 or 0,252525. It's non-recurring and it's non-terminating, which means it keeps going forever and ever, like pi. If you guys have ever seen the numbers of pi, like 3,141, and it keeps going forever and ever, pi is an irrational number. Okay. I hope that makes sense. So things like the square root of 5, the square root of 2, pi, e, there's a number called e, you learn about it if you continue. Tiana says infinity. Infinity is a bit of a tricky one because infinity encompasses all numbers.
And we don't actually know it.
We don't actually know what infinity is, because whatever number you can think of, I can just add 1, or I can even add 0,1 or 0,01 to that number, and it'll still be a number. So infinity is a tricky one. Okay, we don't know whether whatever number you choose, if my next number will be a natural or whole, an integer, a rational, or an irrational number. It's mind-blowing. Guys, maths is just something else. Okay, now I'm glad everybody's got their thumbs up. We understand how these numbers work. Now, your real numbers is just going to be everything. Everything that we've just learned about, everything put together. Your real numbers is your natural, whole, integers, rational, irrational numbers, everything put together. Everything except the square root or the even root of a negative number. I can't find the square root of -36. Okay. It's not a real number. It doesn't exist anywhere in natural, whole, irrational, rational integers. Okay. Or I can't find the 4th root of any number. So as long as it's an even root, like the square root, the 4th root, the 6th root, the 8th root, if I can't find the square root of an whatever number, then it is non-real. So let's say, for instance, you're doing calculations, which you will come across, and you end up with something like the square root of -7. What you're going to write is that -7 has no real solutions. It has no real solutions. The answer does not exist in any of these number patterns that we've described here. Okay, there is a way to describe it. It's called an imaginary number. I wonder who this original person was. Really, real numbers and imaginary numbers. I think they could have named it better, but it's okay.
Person you mean.
So creative. Yeah, so there's real numbers and there's imaginary. We don't work with imaginary numbers until university. Okay, so we're looking at real solutions. So if you find the square root of a negative number, there's just no real solution for that. You can never find the answer for that. Okay, all right. Now, this is just intro. We're actually going to get into what needs to happen now. Okay, we're going to start representing these on a number line, but we're not going to be representing everything like natural whole numbers, none of that. Okay, we're going to be looking at two distinct ones. We're first going to be looking at integers, how to represent them on a number line, and then we're going to look at real numbers. Okay, because if we look at integers, where integers cuts here, integers cuts all numbers that are like whole numbers. So like 0, 1, 2, 3, 4, 5, -1, -2, -3, all of those. And then we're going to look at real numbers because real numbers then takes rational, irrational, and all other numbers, puts them all together. Okay, so we're going to look at how to represent integers on a number line. Okay, so I'm going to need you guys to take out a ruler and a pencil, and I'm going to need you guys to draw your own number line. I'm going to give everyone 1 minute to draw that. Remember, this isn't art class. It doesn't have to look beautiful. It just needs to make sense. Okay, you can make it look like mine. You can extend the numbers if you would like. It doesn't have to be a work of art. We just need to make sure that it's drawn. Once you're done with that, you can put any emoji you'd like in the chat, or you can just write done in the chat if you'd like. Just let me know that we're ready to continue from there on. Okay. Now that I think about it, Teacher Kat, I need to speak to whichever mathematician thought that giving the non-real numbers the name imaginary was all that great.
Could have just left it at non-real. They're like, no.
You know, it sounds a lot more mathematical. Imaginary sounds like we're making things up.
Imaginary sounds like he had some special brownies before he came up with that.
Okay. I hope the kids don't know what special brownies are, but yes, absolutely, it sounds like it did. Yeah.
Sounds like something went haywire there.
You're right. We need to have a conversation with this dude. Ask him, what were you thinking, sir? Like,
someone here needs to be a mathematician and go and
rename it. Yeah, all right. Okay, I'm getting quite a lot of duns in the chat, which is awesome. Thank you, Zondre and Jenica. I see you guys. And Dokozo, Lusanda, Tiana with a laughing emoji, and Anam. Awesome. Hello, Burlington, and Liku as well, and Apiwe. Awesome. All right, let's get this over with. Not over with, on the way. Whew, my English is disappearing, and I'm not even starting school yet. All right, so we're going to think of a number. Now, this number can be any number, but I want this number to be greater than -1. Okay, you guys can pick whatever this number is, pop it in the chat, as long as it's greater than -1. Lesedi just comes out the woodworks with 0. I like it. That's it.
Simple person.
1, 4, okay, 7, 5, 16 million, 3. Okay, excellent. Now, if I have to represent this, right, I know that it's any number, and you guys are all giving me different numbers. You're all giving me different numbers, but every single one of the numbers you've given me has been a different number. So instead of writing out every single one of your numbers, I'm going to call it an arbitrary value. I'm going to call it X. You get to decide what X is. It doesn't matter what X is, but I want X to be greater than -1. I could easily write this the other way around. It doesn't matter. I can write -1 needs to be smaller than whatever number I've chosen. Both of these two things mean the same thing. Okay, but then I tell you that this number X needs to be an integer. It cannot be a real number. It needs to be an integer, which means it's going to have to be a whole number. Okay, it's going to have to be a whole number. Now, how do I represent this on a number line? And here's the kicker. I think Apiwe and let me see who else. Apiwe and Lesedi have already given me the right answer. Which is the number right, the next integer that's greater than -1? What is the next integer greater than -1? That's it, Anam. Good. It's 0. So when I express something as part of the integers and it says that x needs to be greater than -1, I'm going to start at 0 and I'm going to make a dot. I'm going to put a dot here. Okay. Now, after 0 comes 1 because I'm looking at whole numbers. I can't make a line like this. I cannot make a line that joins them. Because if I make a line that joins 0 and 1, I'm including every number in between here, like 1.2 and 1.7. And these are not integers. So I cannot draw a line in between 0 and 1. What I need to do is I need to draw dot for dot for dot for dot. And I need to keep going to show that I'm only including 0 and 1 and 2, 3, 4, 5, 6, but my numbers don't stop at 6. They keep going. So what I do is to show that my numbers keep going, I'm going to draw an arrow like this, and I'm going to put an arrow there. And that shows that I'm going to keep going in that direction, but I'm going to keep skipping everything in between each of those whole numbers. Okay, so I know if x is greater than -1, I'm not going to include -1. I'm going to start with the number just after it. So my numbers will start at 0, 1, 2, 3, 4, dot, 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 dot. Keep going in that direction. Okay, so all the numbers there. Okay, now if I had to say that x needs to be less than, let me write this one out, x needs to be less than or equal to 2. Okay, tell me in the chat, guys, which number am I going to start at? Which number do I start at? X, by the way, x is an element of integers. I'm doing that completely wrong. Anam and Lesedi, remember what this thing over here means. This means equal to. So x can be less than or equal to 2. So where am I going to start? Am I going to start at 1? Not at x. That's it, part 2. We're going to start at 2 because if x is equal to 2, then it must include 2. I will explain again, Burlington. Okay. So because there's a less than and equal to, that line underneath the less than sign means equal to, which means I must include 2. You need to include it in your answer, which means I'm going to include 2 and then go to 1 and 0 and -1, and I can keep going. Okay, Burlington, do you have a specific question? Where exactly did I lose you? Can you let me know where exactly did I lose you? Just so I know where to explain again. You can just pop your answer in the chat. The symbols near X. Okay, do you mean the ones right here in the middle, like this part here? This is something I think we learned for the first time in about grade 6, grade 7 maybe, or even less than that. I think grade 4 is the first time I saw them. On the far right. Oh, okay. So you're talking about this. Okay. You're talking about this. This just tells me that X is an integer. And remember what we said about integers, Burlington? Integers don't include -1, 4. They only include -1 or -2 or -3. So when I write X as an integer, that tells me that I can only include the whole numbers that are either negative or positive. Okay, I hope that makes sense. Angel, I saw that your hand was up. Do you still have a question, my sweetie? If you'd like to unmute. Okay, I'm going to take that as a no. All right. Okay, I need a thumbs up or a thumbs down. Are we okay with how to represent integers on a number line? Give me a thumbs up or a thumbs down, guys. I need to see where I need to explain again. Up here, we're still very confused. That's okay. That's okay. We can do one more example just so we can understand where we're going with this. Okay. Yes, Patu, would you like to unmute for me?
I wanted to ask,
Yes.
like, how do we know where to stop and like put the arrow?
You don't even have to. Like, you can choose. It doesn't really matter where you put the arrow. I could have easily done this. I could have done this. It means the same thing. It means, because I know that I'm including integers, but they must start at 2 and go in that direction. You don't have to include every single number. Okay. The reason why I want us to get used to doing the dots is because of the next example I'm about to show you. Okay, I'm going to show you in just a little bit. Okay. That is a very good question, by the way. Thank you. Tiana, what's up, my sweetie?
Ma'am, I just wanted to know, like, what is the E in the Z for? There on the side.
It means that E means element. Okay, it means element. And it comes in when you learn sets. Okay. It's just something that we show or something that we use to show that X has to be part of the integer group. So that E stands for element and it means part of that group. Okay.
Okay, thank you.
Sure. Excellent. All right. So now here's my next question. If I say to you guys that X needs to be between or needs to be greater than or equal to 4, and it needs to be less than or equal to 4, but greater than or equal to -1. Now, what I want you guys to do in the chat, list all of the numbers for me that will be included in this set. What are all the numbers that I'm going to include in the set? Thank you, Teacher Kat. That actually makes perfect sense. We cannot use equal, so we say E because it could be any of those numbers. Yes, it's not a specific number. It's any one of them. Okay. I want you guys to list all the numbers that can be included in the set from -1 to 4, because X is going to be any of those numbers. Lusanda, remember, we have to include -1 because it's greater than or equal to -1. Okay, do not forget it's greater than or equal to. Angel, where did I lose you, my sweetie? That's a Tatum. That's exactly what I'm. Angel, what's up? Can you unmute for me? I need you to scroll to either your left or your right and click on the button to speak. There we go. Hi, Angel.
Hello.
Hello.
Yes. Please, can you start afresh for me?
Okay. All right. Let's use this example. Don't go away. Don't mute. Okay. So look here. We want X to be any number. We don't know what that number is, but I know that the number must be in between -1 and 4, right? Do you see that? Okay, good. So which is the first number? Which number am I going to look at first?
From +4 to -1.
Good. But remember, -1 is smaller than +4. So I'm going to start at -1 and then go to +4. Okay, so you're right. We're going to start at -1 and I'm going to put a dot like this. Okay. What's the next number where I'm going to put a dot? Where am I going to put a dot next? Remember, we're going to +4. So where's the next place where I'm going to put a dot?
To 0.
Good, 0. 0. I can't, Angel, I can't put a line here because the line means that I'm including everything in the middle. Can I include everything in the middle with integers? No, I can't include everything in the middle. Good, I can't. So after 0, what comes next?
1.
Good, 1. And then what comes next?
2.
Good. And after 2,
It will be 3.
3. And then after 3,
It will be 4.
4. Good. I'm going to include 4. Can I include 5?
No,
Why not?
because it is not an integer.
Okay, good. It is an integer, but it's not included in this set that I want. Do you understand? I
Yes,
only
I
want the numbers in between -1 and 4.
Negative.
Only the
Positive
integers
4.
in between negative. Good. -1 and +4. But remember, the numbers in between -1 and 0, we don't count those. The number in between 0 and 1, they don't count. Only the whole numbers count. And that is why we only put dots on those numbers.
Numbers.
Do you see
Yes,
it?
I can. Yes.
Okay. Excellent. So let me ask you another question. If I said that x needs to be greater than or equal to 1, where am I going to start, Angel?
X. Can I
Think
start
about
with the question?
Yes.
Please give me time to think, to look for the answer.
If you're a little bit lost, have a look in the chat because Liku has given us the correct answer. Okay.
It will be 2. If I'm not mistaken, it will be 2.
Okay, you're correct. We're going to include 2, but remember this says x is greater than or equal to 1. So if x is equal to 1, where am I going to start? If it's equal to 1, if x is equal to 1, I must start at 1 because they are equal, right? If x
Yes.
is equal to 1, I must start at 1. But x is bigger than 1. Which number is going to be greater than 1?
Which number? It will be 2 or 4, maybe.
2, good, but we can keep going. We don't know what the number is. It can be 2 or 3 or 4 or 5 or 6 because the
6.
number only needs to be greater than 1.
Yeah.
Okay,
Yes.
so greater means bigger. So all the numbers from 1 and all the numbers bigger than 1. Okay, and then we can just do this at the end. We can do this. Okay, to show that all the numbers that we are looking for need to be greater than 1. Okay, does that make sense, Angel?
Yes, it makes sense.
Okay, excellent. Okay, I need us to make sure that we're understanding how to write this. Excellent. Can I just take Apiwe's question? I want to see what Apiwe's question is. Apiwe, what's up?
Okay, ma'am. So how would you read the third one we did? Like in words?
Which one?
The third
This
one.
one, the one in green.
No, the one with the x in the middle and then -1 and then -4
Okay,
on the other side.
x is greater than -1, but smaller than 4.
Okay.
Because it's in between the two of them. Okay.
Okay. Thank you.
Excellent. You're very welcome. Okay, I'm going to need a thumbs up or a thumbs down from you guys in the chat because I feel like this one was a bit of a challenge for you guys. Okay, let me know in the chat. Thumbs up or thumbs down. How are we feeling about this? Okay, I'm seeing a couple of thumbs up. Thanks, Inam. I don't know what the angry face is for. Isa and Simpiwe and Burlington, excellent. And Lusanda, well done. Okay, guys, remember, if you don't understand anything, I'm happy to explain. Okay. We will. That's in Dokozo. You will get there. You just need to practice. It all takes practice. Okay. Well done. All right, guys. Excellent. So this is how we express integers. And I'm so sorry, Patu, we do not have a brain break today. Okay. It's because of the amount of work we need to get through. We can only have brain breaks after next week. I'm so sorry. I am so sorry. We just have a lot of work to get through.
Mata has been working overtime,
Yeah.
hoping to have a brain break.
Yeah, I'm so sorry, guys. I'm sorry. I will try and squeeze one in next week, but with the amount of work we need to get through, yo, guys, I swear. Okay, all right. That was integers. We're going to have to look now at real numbers. Okay, now we're going to do the exact same thing. It's just that real numbers are going to work a little differently because real numbers, we include everything in the middle. Okay, I actually have news about Brian for you guys, so just hold on there for a second. Okay, all right. So if I said to you guys that x needs to be greater than -2, okay. If this was integers, you guys would tell me that x needs to start at -1. But with real numbers, it's a little bit more tricky. Okay, Apiwe says, no, ma'am, please give it. Okay, I'll give you time. You can draw a number line. Okay, okay, you guys have got a minute. We're going to look at real numbers. Let me know when you're done. Remember, it doesn't have to be a work of art. Anam is done. Yes, it doesn't have to be a work of art. It'll be fine. Just draw a line. Just draw a line. Hello, Nazarene. Excellent. All right, good. All right. So Burlington, R stands for real numbers. Okay, real numbers. And if you remember, we just went through it over here. Real numbers means everything. All of these different numbers fall under real numbers. Okay, we've just gone through it. Okay. It's not that bad, I promise. If you're still a bit lost, you might need to rewatch the beginning of the lesson just to get an idea of what we're talking about. Okay. All right. So if I had to ask you guys about x being greater than -2, if we were talking about integers, you would all say, ma'am, we're going to start at -1 because x is greater than -2. We can start at -1. But because we're looking at real numbers, we can't start at -1 because everything in between here, right before 2, is also included. All the stuff over here is also included. Okay, it's included as well. So what we need to do, okay, is we are going to draw a dot right above -2. That's it, -1,9, Anam, that's it, -1,9, or even -1,99, or -1,999, or -1,99999. Everything right before -2. So what we're going to do is we're going to draw an open dot right above -2. And because x is greater than -2, we are going to draw a line going that way. And do you see now how we don't have dot after dot after dot after dot? It's because for real numbers, everything in between here is included as well. So we draw a solid arrow. Okay, a solid arrow. But the reason why I don't color in my dot is because -2 is not included. It's not. So if I have a greater than, a sign for greater than, when we're talking about real numbers, I draw an open dot. If I have a sign that says greater than or equal to, I'm going to draw a dot and then I'm going to color it in. Okay. So open dot is just for greater than. A closed dot is for greater than or equal to. Remember that this line over here, this line means equal to. Okay. That's it. That's exactly what I was trying to say. Teacher Cat says -2 is not included, but -1,9999999 is. So you cannot start at -1. We have to start right before -2, and we don't know what that number right next to -2 is. So we're just going to put the dot on -2, and then we're just not going to color it in. So technically, everything that we're including starts right after that. That's where it all starts. Yes, Lusanda.
Miss, could you please repeat what you said about the dots?
Okay, so do you see how this sign over here is just a greater than sign, right?
Mm-hmm. Yes, miss.
So if it's a greater than sign, I just draw a dot. Don't color the dot in. Okay, the second I do this, if I go greater than or equal to, if I put that extra line there, then I have to go to my dot and I color it in.
Okay, thank you, miss.
Excellent. You're very welcome. Okay, well done. All right, so that's all that means. If I don't include, if it's just a greater than or a smaller than sign, I just include an open dot. But as soon as I go greater than or equal to or less than and equal to, then I need to put in a closed dot. I need to color my dot in. Okay, I'm going to give you guys a chance to do one yourselves. Here's the next one. I want X to be less than or equal to 3. No, Lesedi, it doesn't matter where the line ends. Okay, you can draw the line as long as, or as short as you want. The important thing is the dot. I want you guys to draw this one for me. X is less than or equal to 3. Now, before we even go there, which way is my arrow moving? Is my arrow moving to the left or to the right? That's it, Anam. 100%. Because it's all the numbers less than, smaller than 3. Okay, so go ahead and draw this one. X is less than or equal to 3. I'm glad you think so, Anam. That means the kids at my school are very lucky. I like the sound of it. Okay, excellent. I think this one is quite easy, right? So I'm going to go to the number. I'm going to go to 3 and I'm going to put a dot. Tell me in the chat, everyone, am I going to color it in or am I going to leave it open? Open or colored? Open or closed? Anam says open. Burlington also says open. Remember what the equal to signs means. Ndokozo says closed. Said colored dot. Hey, Liku says closed. Good, closed, because the equals to sign means that I need to color it in. I must color it in because it's less than and equal to. That equal to tells me that I need to color it in. And then I can draw my arrow going in that direction. Okay. There we go. That's my arrow. Okay, one more. Let's do another one. If X is less than 5, tell me in the chat, open or closed dot. I already know it's going to be at 5. Am I going to color it in or leave it open? Open or closed? Let me draw a better dot. Everybody's saying open. I like it. That's because you're correct, 100%. Now, x needs to be greater than 5. Which way is my arrow going? Am I going left or am I going right? It needs to be greater than 5. So I need to go to where the numbers are bigger. Burlington, which way are my numbers bigger than 5? Yes, you just like left, no, right. Yes, we're going to the right, my sweetie. That's it. We're going to the right, this way. We're going to the right. Okay, that's it. Because it's all the numbers greater than 5. 5 not included. Okay, now here's a tricky one. Let's look at a tricky one. Yes, Patu, go ahead with your question while I write down the next example.
Ma'am, I wanted to ask, like, when they ask us a question like this, are they going to tell us whether x should be like rational number, irrational, natural number, whole number, integer?
Yes, absolutely. But like I said, in this case, in the case of number lines, it's a lot easier for them to only ask you about integers or real numbers, because everything else in between gets a little bit tricky. Imagine if we had to do rational numbers. Rational numbers are fractions. How are we going to draw a dot for every single fraction in between here? That's going to be too difficult. It's not going to work. So instead of going to rational numbers, we go straight to real numbers, because real numbers will include everything in between there. And then instead of doing whole numbers, because whole numbers cut out this entire section of the number line, we just do integers, because integers can include all of that. Okay, so they split it at integers and at real numbers because it's easier for us to get. Okay, Lusanda, what's up, my sweetie? Hi, Lusanda.
Miss, does x ever be a specific number?
Not really. It could, but that's when we're talking about equations. But in this case, we're looking at all the different numbers that it can be. Okay, we're talking about inequalities and not equations. Okay.
Thank you, Miss.
I could do this. I could do this actually. I could go, if x is greater than or equal to 1, or less than or equal to 1, and also greater than or equal to 1, then there's only one number that x can be if it needs to be in between 1 and 1. And the only number that x can be in this case is 1. But this is nonsensical. There's no need for us to do something like this, because we know that any number in between that's greater than or equal to 1 is going to be 1. Okay, but there's no point in us doing that. If we do something like that, it's probably a trick question, and we're trying to trick you. Apiwe, how can I help, Miss Vicky? Hi, Apiwe.
Hello, ma'am. So you said -2 is less than x. Is that supposed to be a greater than sign, or is that supposed to be a greater than sign?
That means that x is greater than -2. Okay, so x needs to be a number bigger than -2, but it also needs to be a number smaller than or equal to 4. Okay, so don't go away, Apiwe. What's going to happen? Where am I going to draw a dot? I'll give you a hint. There are 2 dots. Where are my 2 dots going to sit?
Above -2 and then above 4.
Good. Am I coloring any of them in?
You're coloring the one for 4.
Good. How do I put these 2 things together? What am I going to do?
Just draw a line.
Excellent.
Connecting the dots.
That's it. I just draw a line that connects this dot to that one. And you're done. Bob's your uncle. That's it. Very, very well done. That's what I was looking for. Apiwe, you're a whole rock star. And Belinda's like, maths has evolved on a way harder level than last year. And I did tell you guys that maths was going to just, oh. Okay. But remember, guys, this all takes practice. It's all practice. Okay, so draw yourself a number line, choose x is equal to for yourself, and just practice. Make sure that you've got it. Yes, Tiana. You can unmute for me, Tiana. You have a question?
Yeah, ma'am. My question is, are they like gonna give us this in class tomorrow? Because we like only starting. I'm only starting tomorrow. Like, are they gonna ask us to color the dot and open the dot?
Yep, 100%. When you go to class tomorrow and your maths teacher's like, let's start at the beginning. This is going to be the beginning that you learn about. Okay.
Thank you.
You're very welcome. Okay, you're already ahead of the curve now because you've already learned it. Okay, Liku says, so had x been integers, would there still have been a line between those two numbers? No, it wouldn't have. Okay, if x had been an element of integers, this is what would have happened. We wouldn't have been able to draw a line and our dots would start here. Now, they wouldn't be able to, the dot would not be able to include -2. So we would have to start at the number right next to -2, which would be -1. So we would start our dot there. And then we would include 0, 1, 2, 3. And because x is equal to 4, we would also include 4. That's how it would look like. Okay, I hope that was helpful. Good, that's it. Thank you, Teacher Kat. Okay, open dots are only for real numbers. Okay, all right. On a scale from 1 to 10, how confident are we with representing numbers or arbitrary numbers on a number line? Let me know in the chat. Choose any number between 10 being, ma'am, I'm with you, I got you. 0 being, hi, ma'am, that's us. I don't know. This is where we will pick it up on Thursday. Liku says he's confident. Anam is at a 10 out of 10. I need to ask this though. Patu says 8,55666. I see the 8. I need to know what the 55666
She's practicing her bargaining irrational.
Rational number, yeah, rational and irrational numbers. I see you. That's actually a rational number because it's terminating. But I've got you. Lesedi says it's at 100. That's good. Ntokozo's at a 7. Isa at an 8. Simpiwe at a 9. Angel at a 6. Okay, excellent, guys. Liku is also at a 10. That means that when we come in, Burlington is at a 0. When we come in,
You
Burlington,
definitely changed it.
I think he did change it.
I see
Burlington,
you.
I think you need to go practice. Just pick your ruler, draw a number line. Thanks, Virginia and
And
Zandra.
he joined late. So I
Okay,
think that's
draw a number line. Yeah. Just go ahead and draw a number line, guys, and just pick a random number. Say, I want x to be greater than 4. And then see how it's going to be drawn. And choose integers. Say, okay, I want x to be greater than 4, but it needs to be an integer. What would that look like? Okay,